Here are the objectives and some basic information for this section. Again, talking about the different pieces that make up an angle. And you'll want to maybe pause and take a look at this as you need to. Here, again, looking at angles, we oftentimes use the Greek letter theta to name an angle. Specifically looking here at acute angles being between 0 and 90, right angles equaling 90, obtuse angles being between 90 and 180, and a straight angle being an angle that measures exactly 180 degrees. Also, the idea that complementary angles are angles that add up to 90 degrees. Supplementary angles are angles that add up to 180 degrees. So first question down here, for an angle that measures 40 degrees, find the measure that it is its complement, and then part 2 is its supplement. So again, remembering that complementary angles add up to 90, again, you could set up an equation, but you could probably just tell that 40 plus 50 would be 90, so the complement to 40 degrees is 50 degrees. And again, supplementary angles add up to 180 degrees, so angles that are, or the supplement to 40 degrees would be 140 degrees. Here are some typical type of questions that we have when we deal with this kind of a thing. So in this diagram, it's a 90-degree angle, and it's comprised of really two other angles, the 3x that measure 3x and 6x. So what we could do is write an equation for that. 6x plus 3x equals 90. We can combine the x's to get 9x equals 90, divide by 9 to see that x is 10. Now here, pay attention that they do want you to find the measure of each angle. So just finding x equals 10 is not really the answer. What we actually look at then is that the 6x would be 6 times 10, so 60 degrees. And the 3x would be 3 times 10, so 30 degrees. And that should make sense because 60 plus 30 equals 90. In this other diagram here, it's clearly a straight angle formed from the 4x and the 6x. So again, you might even jump right to a 10x, but you could write out 4x plus 6x equals 180. So 10x equals 180. Divide by 10, we get x equals 18. Again, just finding x is not the answer. We want to find the measure of the marked angles. So 4 times 18 would be 72. So that's 72 degrees. And whether you do the 6 times 18 or just subtract the 72 from 180, either way you get 108 degrees for the angle marked with the 6x. Just adding these angles together. So 51 degrees, 29 minutes. So with this one, again, it's combining the 51 and 32 to get 83. 29 and 46 makes 75, but 75 minutes is over 60 minutes. So that's 1 degree and 15 minutes. Add the 1 degree to the 83 degrees, we get 84 degrees and 15 minutes. One of the problems with this second one is that we don't have any minutes to take the 12 minutes away from. So a strategy for being able to handle that is to borrow a full degree from the 90, so we're taking it down to 89 degrees. But that 1 degree is the same as 60 minutes. So it's similar to taking and making change. So then we can subtract the 12 minutes from the 60. So 60 minus 12 would give us 48 minutes. 89 minus 73, now we'd be talking 16 degrees. So again, just one way that you can handle that. Now converting to decimal degrees, from degrees, minutes, and seconds to decimal degrees to the nearest thousandth. Again, just to kind of talk you through that, or maybe I'll just do this. So the 14 seconds, if we divide that by 60, that will convert that to minutes. So we can add that to the 8, and so then that's all in minutes. And so then if I divide that by 60, then that would be degrees, and then I can add that to the 74, and I would have degrees, minutes, and seconds. Now most of that's going to be calculator work that you're going to have happening there. And if you can figure out how to type that into the calculator, it'll also do that for you as well. And that turns out to be 74.137 to the nearest thousandth degrees, of course. And there's a 2 repeating after that, but that is to the nearest thousandth. Converting the 0.817, 34.817 to degrees, minutes, and seconds. So it would be 34 degrees. And then we multiply the 0.817 by 60. It gives us 49.02. So that's 49 minutes. And then we multiply the 0.02 by 60, which is 1.2, and that's how many seconds we have. So 30 degrees, 49 minutes, and 1.2 seconds. Again, graphing calculators will often have a way to do that as well. You just type in the decimal and then find the button or way to convert that to degrees, minutes, and seconds. Again, here's some just information about initial sides and terminal sides and what it is for an angle to be in standard position. So go ahead and pause and read through that. Again, kind of continuing that, the idea of coterminal angles. So you can see here, here we just have a short 60-degree rotation, or you can go all the way around and make a 420-degree rotation and end up in the same spot. So those are coterminal sides. Also see here a 110-degree rotation, or all the way around once, and again, and then 110 more for an 830-degree rotation, which is coterminal with the 110 degrees. So here looking for angles of least possible positive measure that are coterminal with each one. So really just subtracting full rotations until we get to a rotation that's less than 360 degrees. So with the 908, we're really 2 full revolutions, or over 2 full revolutions away. So 1 full revolution being 360, 2 being 720, we can subtract the 720 from 908. 3 full revolutions would be 1080, or 1080 degrees, so we're not quite there yet, so we have to just subtract the 720. And that leaves us with 188 degrees. So now I have a better understanding of where that is. I know it's just 8 degrees past 180. For the negative 75, it's less than 1 full negative revolution, so I can just add 360 to that. And I end up with 285 degrees. So a negative 75-degree rotation is the same as a 285-degree rotation. And now negative 800 degrees, if I added 720, I'd still be at negative 80. So I would add 1080. And so I end up with 280 degrees. So negative 800 would be the same as 280 degrees. And then for this last one, we have 480 revolutions per minute. And so we're really going to convert that to degrees per second and then do 2 seconds. So again, this is revolutions. So to convert the rotations or revolutions to degrees, there's 360 degrees per revolution. So we'd multiply that, 360 degrees per revolution. Again, just a regular kind of conversion there. The revolutions would cancel out, so we'd be left with degrees. And then this gives us the time in minutes. So we want to convert that to seconds. And again, this is time, minutes, and seconds, not rotation, minutes, and seconds, being a difference there. So we would multiply by 1 minute over 60 seconds. And again, just a little simpler to just go down to 1 second. So this would get us down to 1 second. Now they want revolutions per 2 seconds. So all I would do then, because this amount again would be degrees per 1 second, so I would just multiply by 2 to make it 2 seconds. And we end up with 5,760 degrees per every 2 seconds of time. Again, thanks for watching, and hopefully all of this helped.